Well, hello, I'm Mr. Malden, and this is the Math Toolbox, where I show you how to become a middle school math master. All right, today's lesson is over adding and subtracting integers, so we're going to go ahead and get into it. Every day, I like to start my classes with a bell ringer, so you can either skip this part if you don't want to go through the bell ringer, or you can just watch this part where I go over a concept that may or may not be related to the day's lesson. But the bell ringer today is the table shows a portion of the day 4 students use to build a website. Write the order of the names in order from greatest amount of time used to the least amount of time used. All right. This comes from the previous day's lesson of ordering rational numbers. All right. So you've got this situation here where you've got 4 students who've spent a portion of their day represented right here as percents and fractions, and so we're asked to order them in order from greatest amount of time used to least amount of time used. So the first thing we need to do is we've got to get these to like notation, either all percents or all fractions with a common denominator or all decimals. Personally, I like to make them decimals. So we're going to take Jamel's, which was 49.4%, and we're going to convert that to a decimal because this is not decimal notation. Because that percent sign is right there, that means it changes things. This is not 49.4, this is 49.4%, all right? Which changes things. Anything less than 100% is going to be less than one whole. It's just going to be part of one whole, right? So in order to change this to a percent, really all you need to do effectively is move the decimal places 2 places to the left and erase the percent sign. Mathematically speaking, that's the same thing as dividing by 100, all right? So Jamel's percentage can be changed to a decimal just by dividing by 100 and removing the percent sign or moving that decimal 2 places to the left. Those are the same things, all right? So his is 0.494. Andrew, just like Jamel is represented as a percent. So again, we just need to move that decimal 2 places to the left. So you've got 0.376, all right? Then you've got Ernesto, all right? His was represented as a fraction, all right? So we need to take this fraction and we need to make it a decimal. The way that I use it, do that is by recognizing that fraction bar is really just division, where your top number is being divided by the bottom number, all right? When we divide 7 by 25, 25 goes into 7 0 times, which would prompt me to take my decimal to the top, add a 0 after the decimal. 25 goes into 72 times, because 2 times 25 is 50, and 70 minus 50 is 20, so we need to bring another 0 down to work with it, all right? 25 goes into 200 8 times, all right? Because 8 times 25 is 200, and 200 minus 200 is 0, so we have a remainder of 0, so we know now that the answer is 0.28. You could also put that on a calculator as 7 divided by 25 just to check yourself, and the answer is going to be 0.28. So Ernesto has 0.28, and then finally you've got Blake, all right? His is 3/10, and just by reading that 3/10, it kind of prompts me to know I just need to put a 3 inside the tenths place value, but I could just divide 3 by 10 as well, and I would get 0.3 either way. So Blake's is 0.3. So we have these 4 times, all right, portions: 0.494, 0.376, 0.38, 0.3, and then once you get them all to the same notation, it's pretty easy to see which one's the biggest one, all right, because we're going greatest to least. The greatest one is going to be the one that's, has the 0.4. So when you're going to greatest to least, trying to figure out which one's the greatest, you're going to start from the left and go to the right, all right? So the first number after the decimal is 4 for Jamel, 3 for Andrew, 2 for Ernesto, 3 for Blake. So Jamel's is first, all right? Andrew has 0.37, Blake has 0.3 nothing, so we're going to put a 0 there just to be able to compare it, all right? 7 is greater than 0, so Andrew's is next, then Blake's is next, and then Ernesto's is last. So that's the order: Jamel, then Andrew, then Blake, then Ernesto, all right, for your final answer. All right. Okay, so that was the bell ringer. Then we kind of just went over really briefly the classification of numbers because our objective today is to to add and subtract integers. All right, we needed to have just a little bit of a refresher what an integer is. An integer by definition is 0. And then all positive counting numbers, so numbers starting at 1 without decimals and going to infinity. 1, 2, 3, those are all counting numbers, all right? And then they're opposites. The counting number is opposite. So like the opposite of 1 is -1. The opposite of 2 is -2. So it's going to include all of those numbers. That's the technical definition. The way that I'd like to describe it is any positive or negative complete numbers. Those are integers. So really all we're concerned about today is adding and subtracting positive and negative numbers, all right? So we can go ahead and get on into the lesson, all right? The way that I taught this, in maybe the way that many teachers teach this, is we like to teach tools, all right, to be able to add and subtract integers. Let's just start with adding. Everything for right now is going to be about adding. The three tools that I like to teach students are counters, a number line, and then this thing called a tug line, which I'm going to show you here in just a second. With counters, that's what we're going to start with. We have to teach this concept of a zero pair, all right? A zero pair is a pair. Zero pair describes a pair of numbers whose sum equals 0. So a zero pair is two different numbers, all right, that when you add them together, their answer is 0. And the only two numbers that you can add together and equal 0 are opposites, like -1 plus +1, all right? That's a zero pair. Or -10 plus +10, or -5 plus +5, or 28 plus -28. All of these equal 0. And so all of these would be considered zero pairs, all right? Well, the reason why we have to talk about zero pairs with counters is when we have counters, all right, and you're adding integers. Let's just say we're doing 2 plus -3, all right? I'm going to have two positive counters here, and I'm going to have three negative counters right here, all right? Well, the reason why we talk about a zero pair is we need to understand that a positive and a negative will cancel each other out, because when you add that positive and that negative to each other right there, because that's a +1, that's a +1, or a -1, when you add those two together, it's going to equal 0. So that's a 0 right there. Here's another 0 right there. That makes all that go away, and all that's left is one negative. So the answer would be -1. So we teach the zero pair to help you understand that a positive cancels out a negative, or vice versa. A negative cancels out a positive, all right? Let's get into these problems. I actually did 2 plus -3 as that example, but here's another one. So the way that I started out in class is I made everybody write this out. So maybe as we go along, I'm not going to pause too much in this video, but try to stay along with me. Maybe you can have a scratch sheet of paper that you can be working with me. You can try it yourself, and then you can see when I show it to you if we got the same answer, all right? So the first thing I had them do is just represent these as counters, all right? So you've got -2 plus 3. We just need to represent that as counters. So that's the -2 and plus -3. So we need to put 3 pluses out here just like that, right, for counters, all right? And then you can cancel out your zeros, all right? So a negative cancels out a positive, another negative cancels out another positive, and then you recognize what do you have left over? You have one positive. So -2 plus +3 equals +1, all right? Pretty simple, all right? So we'll go on to this next problem. There you go. There's some illustration for how the zeros cancel each other out. All right, so we can go to this next problem, all right, which is 3 plus 5. Now, this is a first grade problem, all right, so we're not just trying to make you do first grade problems in 7th grade, but the objective simply is to show this as counters. What would it look like? So just take a second real quick. Show me what this would look like as counters, all right? This is what I have, all right? So you've got 3 positive counters, and you have 5 positive counters right here. So how many positive counters do you have altogether? You have 8, all right? Next problem, -3 plus 5, all right? how would you represent this as counters? All right. I say 3 negatives right here, 5 positives. Then 3 of these negatives right here are going to cancel out 3 of these positives, and what you would have left would be 2 of the positives. Okay, just for clarity, I'll go ahead and do that on this whiteboard as well. So we had -3 plus 5, all right, which means I've got 3 negatives, all right, 5 positives. All right, and 1 negative cancels out another positive. 1 negative cancels out another positive. Another negative cancels out another positive. And what do we have left? We have 2 positives left over. All right, so that's how you use counters. All right, and counters are really great for when you're trying to learn adding positive negative numbers from the very beginning with small numbers. But there's a breakdown with counters when you start to get to big numbers like this, all right? We could technically represent 24 positives and 32 negatives, all right? This one's not too big of a problem, all right? But it does get a little tedious to write all those counters, but just think about, what if I were doing 1,837 plus negative 2,168, all right? Do you really want to spend all day writing 1,837 plus counters and then or positive counters, and then 2,168 negative counters, and then do you want to spend all of the next day like scratching off one for one and then counting up what you have left? It's not practical, is what I'm trying to say. So number lines are great when you're first starting out, but they're not great with working with like big numbers, all right? So did I say number lines? I said counters, all right? I was previewing for the next tool. So counters are great when you're first starting out, not great for big numbers. Same thing with number line. Number lines are really great when you're first starting out. A lot of teachers rave about number lines. They really love them. I'm not one of them. You know, it's not my personal favorite because it has the same limitations as the counters do, all right? Yes, it's good when you're first starting out because, you know, you can locate the first integer on the number line, that's like -4, and then you're adding the second integer, which means we're hopping 2 places to the right because that's a positive, all right? So when we start at -4 and we hop 2 places to the right, we end up at -2, which is the answer to this problem, all right? It's great for this kind of situation. It may be even great for like a situation like this where you've got -3 plus 5. These are both still small numbers. On a number line, it would look like this. I'd represent 0, -1, -2, -3. That's where I would start. And then I'm going to hop 5 spaces to the right because it's a +5. All right, so I'm going to hop 1, 2, 3, 4, 5 spaces. And then I got to come back over here and make a recognition of where I ended up. Well, if that's 0, then that's 1, and this is 2. So I ended up at 2, so the answer to -3 plus 5 is +2. Again, just like with the counters, this is a great tool for when you're first starting out and you have small numbers like these, but when you get to big numbers, it starts to become impractical. You could still do it with this 24 and -32, but you're going to have a number line that's going all the way to +24, and then you're going to have to hop backwards 32 spaces and figure out where you landed on the negative side. Okay, so again, it breaks down when you have bigger numbers, all right? That brings me to the tug line. This is my favorite tool for adding positive and negative numbers. A tug line, so let's just back up for a second and let's just use this. I'm going to teach it with this bigger problem, 24 plus -32. 24 plus -32. First of all, a tug line, you have to learn how to draw it, all right? In order to draw a tug line, you draw a big T, just like this, all right? You're going to have a positive side and a negative side, all right, just like that. I like to put the positive side on the right and the negative side on the left because on a number line, positives to the right, negatives to the left. It ultimately doesn't really matter which side you make positive or negative, just so long as you have a positive side and a negative side. put a total bar at the bottom, just like this, and I put a total bar over here at the right, just like that. It helps me know that I have two things that I need to do, all right? And then you start going through and you put the numbers on the team that they belong to. So this is called a tug line. This comes from like the concept of a tug of war, which, you know, adding negative numbers is like a tug of war, all right? So we're going to start out by putting the numbers on what team they belong to. 24 is positive, so it goes on team positive, right? 32 is negative, so it goes on team negative right here, all right? Then once you get them on their individual teams, you add up your team totals, which is really easy for this one because you've got only one number that's negative and one number that's positive. So the team total for the negative side is negative 32. The team total for the positive side is 24, all right? Now then, if you have both a positive and negative number like this, all right, then there's going to be a war. There's a tug of war between these, and the war means we're going to subtract these two numbers, all right? We're going to just thinking about the number, not thinking about the sign right now. We're just going to find the difference between these two numbers. So 32 minus 24 is 8, all right? And then once we find the difference between the two, we ask who won the war, all right? Well, the negative side did because they had more Army members, all right? They had more on their team. So then the answer is going to be negative because the negative won the war. So 24 plus negative 32 is negative 8. And I found that by using a tug line. Tug line doesn't break down no matter how big the numbers are or how many numbers you have. If you have a lot of numbers, then you're going to continue to be able to use a tug line. So go ahead and try this one on a tug line. 4 plus negative 11, all right? And you may want to pause this video right now because I'm going to go ahead and show you the answer, but try to put it on a tug line. Pause this, all right? Put it on a tug line and then come back and see what the right answer is, all right? All right, so we're going to assume that you already paused. And now you're ready to see what the right answer is. If you haven't yet, haven't tried it, go pause it and try it yourself, all right? Here we go. I've got a tug line, all right? I'm just going to draw my T, total bar at the bottom, total bar at the side. I have a positive side and a negative side. 4 is on team positive. 11's on team negative, just like this. Add down, so what's your team totals? So 11 plus nothing is 11, all right? So I have 11 negatives, 4 positives. Is there a war? Yes, because there's both a negative and a positive number. There's going to be a war. So when there's a war, we find the difference between the two numbers. So 11 minus 4 is 7, all right? And then who won the war? Well, 11's a bigger number than 4 is, so the negative side won. So the answer is a negative 7, just like that, all right? All right, let's go to the next one. You can try this one. Now we've got more numbers. We've got 14 plus negative 12 plus 5, all right? So go ahead and try this one. Pause the video, if you will, and then come back to it, all right? I'm going to go ahead and move forward, so if you haven't paused yet, you probably should do that. But here we go. We're going to make a tug line, all right, just like this. Positive side, negative side. We got 14 on team positive. That 12, the reason why we put that negative 12, the reason why we put that in parentheses is just to make it explicitly clear that's a negative number. If we didn't put that in the parentheses, you might see a plus negative or plus minus and get a little confused. So, you know, mathematically, a lot of times we'll put the negatives in parentheses just like so it's really clear that's a negative number, which means that 12 is on team negative, and that 5 is a positive number, so it's on team positive, all right? We'll go ahead and add down the team total for the negatives, which is only one number, so that makes it really easy. There's just negative 12. On the team positive, we have 14 plus 5 is 19 positives. Is there a war now? All right, yes, there's going to be a war between our two totals. 19 minus 12 is 7, all right? And the bigger team was the positive team, so it's going to be a positive 7, right, which we could write like that, but with positive numbers, we don't put a sign there. It's just 7. That's the answer. All right. Last one. Let's try this one. Okay. You've got 4 numbers now. All right. 4 numbers. So go ahead and write those numbers down. Pause the video. Try it yourself on the tug line. See if you can get the right answer. Okay. We got 13 plus negative 45. The bell's going to ring here any minute. And then I'm going to have students coming in. There it goes right there. All right, let me finish up, show you this right here. All right, we're going to put these on a tug line just like this. All right, we've got 13, 45 goes on the negative, 3 goes on the negative, 22 goes on the positive. Team negatives total is 48 negatives. Team positive is 35 positives. Is there a war? Yes. 48 minus 35 is 13, and the negative side won the war, so the answer is negative 13. And you can do that really fast, all right? Now then, let's go ahead and move forward, because I want to show you also subtracting integers, all right? So with subtracting integers, we're going to skip this bell ringer right here. And we're going to skip this conversation about using the counters, and we're just going to go straight to using a tug line. So I'm skipping through all of these with counters because I showed the students how to use counters and then ultimately told them that I don't like the counters very much because, you know, it breaks down with big numbers. So my math toolbox right here, I have a tug line listed, and then I have this process called KCO, which stands for keep, change, opposite, all right? When you've got a subtraction problem, you can turn this into an addition problem by applying keep, change, opposite. You're going to keep the first number the same. You're going to change a subtraction to an addition problem, and you can't just stop there. If you stop there, you change the complete problem. But you have to go on and finish the process of changing the final number to its opposite, all right? So 9 minus negative 7 is the same thing as 9 plus 7, all right? And then that one's pretty easy. Those are just two positive numbers. The answer is going to total up to 16, all right? So let's go on to one that would have positive and negatives, all right? Again, we're going to keep the first number the same, so we would keep negative 4 the same. We're going to change the subtraction to addition. And we're going to change that next number, the negative 3, to its opposite, which is positive 3. So there you go. There's the process that has been applied to this problem. These are the same exact problems. Now it looks like we've changed different things, but because we changed subtraction to its opposite and we changed the next number to its opposite, then the problem has essentially stayed the same, all right? And the illustration that I gave in class was kind of a silly one. When I lived in California, there was this Chinese food restaurant that I like to go to, all right? And but I had to go down a really busy road to get to it. So this is my car going. Well, I couldn't turn left right here because there was a sign right there that said no left turns. So what I had to do in essence, to be able to get to my Chinese food restaurant, is I had to go up past the block, and I had to turn right. Then I had to turn right again, and then I had to turn right again where I could go through that light and get to my Chinese food restaurant. So I learned that 1 left equals 3 rights, right? Just like that. So if parents ever say, well, 2 wrongs don't make a right, well, you can make them think a little bit. You can say, well, but 3 rights make a wrong. 3 rights make a left. So it's kind of a funny joke for the day. Anyways, but that's kind of just illustrating that. Yeah, 1 left looks different than 3 rights, but effectively they're the same thing. I couldn't turn left here, right? So instead I went up and I made 3 rights in order to be able to get to where I wanted to go. Well, the same is true kind of mathematically, all right? Yeah, these look different, all right? But they're not different problems. They just look different. Effectively, they're the same thing. And then once you change it to an addition problem, you can finish up by putting these on the number line, all right? The tug line. So you've got team negative, team positive, all right? Is there a war? Yes, okay, and negative won the war. All right, we're going to conclude the video with that. Email me or message me if you have any questions. Have a great day.